in related rates problems, we're going to find rates of quantities that are changing in conjunction with other quantities that are also changing, right? So for example, like with the optimization, it was like we were just varying, like one side of a square to see how the area changed or something, right? Here, 2 or 3 things might be changing at the same time, and one rate is related to the other. All right, so in order to do related rates problems, we first have to review some implicit differentiation. Okay, let's really review though. Okay, so look, if I have d dx of x squared, you guys remember that? d dx of x squared, that's just what? 2x, plain and simple, that's it. Because the variable is x, right? X squared, the variable is x. And the variable with respect to which you're taking a derivative is also x, okay? But now if I have d dx of y squared, now my equation is in y, but I'm taking a derivative with respect to x, a different variable. So this is now going to be 2y dy dx. Do you remember that? Okay. So, and the reason for that is because this is a different variable than that. Well, if we're talking about rates, though, things are changing with respect to time. So we're going to be taking a derivative with respect to time. So if I were to take d dt, derivative with respect to time, of these, let's see what happens. So here I get d dt of c is equal to d dt of 2 pi r. So now I have dc dt is equal to, all right, 2 pi is a constant. It moves to the front. And I have dr dt. And with that, I can't do anything else. That's it. It's done. Okay? Because dr dt, these are different variables, so it just stays that way. Okay. Now, take a look at this next one. I want to do d dt of a, which is d dt of half bh. Now, here, this is da dt is equal to. Now, here I have the derivative of b times h. And both of these are different variables than this ddt, right? So this becomes a product rule situation. So this is u, and this is v. So now if I were to do uv prime, it's half b dh dt plus half db dt times h. And we're going to leave it like that because this is really like, it's not a full problem. You'll see later how it'll simplify. Okay? Are you sure? Okay. All right. So take a look at this one. This is a little bit different. We have v is equal to pi r squared h, where h is equal to 4. What this is telling us is h is just a constant 4, right? What happens if I take a derivative of a constant? It's just 0. There is no change, right? There is no rate of change. So what I do is, because it's a constant, I plug it in here. So now this becomes v is pi r squared times 4, which is, let me just write it this way. 4 pi r squared. So dv dt is d dt of what? 4 pi r squared. Okay, now. Right, so this is, the 4 pi will come out, right? And then it's times 2r dr dt. So dv dt is 8 pi r dr dt. Isn't that fun?
8 pi r.
Dr dt.
Yeah.
Yep, okay.
Wait, are you doing the dr dt because it's the chain rule?
Yes. Next one, tangent of theta. So function is y. What's the variable in the function? Theta, right? So dy dt is d dt of tangent of theta. And you know what? I'm going to say that in a different way. Basically, what I'm doing here is I want to take a derivative of tangent with respect to t. I feel like if I say it in those words, then it's clearer what I want to do. I want to take a derivative of tangent, which is secant squared theta, but with respect to t. So times what? D theta dt. Yeah? Yep.
Can you write dy dt on the left side every single time?
Yeah, so once we start solving like actual full-fledged problems, you'll see why. Why, get it? You'll see why? Never mind.
No, I get it.
All right.
I just finished the problem, that's why.
Ben's like snubbing me over here.
No.
I'm kidding. All right. So, here we go. We have a right circular cone. What is a right circular cone, you ask? It's, your average snow cone, right? The radius, height, and the volume are related by that equation, 1/3 pi r squared h. How is dv dt related to dh dt if r is a constant? Okay, in math, when they ask you how is one thing related to another, we're not looking for like, aunts and uncles. Like, it's like, what's the equation that connects the two of them? So let's see. Well, v is that, right? So what I'm going to do, 1/3 pi r squared h, I'm going to take d dt of both. But now, look at what it's saying. It's saying r is a constant. So the 1/3 and the pi are constants. Well, now the r is also a constant. So it's like pi/3 times like 5 squared. So all of those things are constants together. So they can all come out. So dv dt is pi/3 r squared dh dt. Right? The r is like 5 squared. It's a coefficient. Okay? All right.
And why isn't h a coefficient too, since it's constant?
H is not. It's not telling you that it is in that problem, part A.
Okay.
Yeah? Yep. Now, part B, it says, how is dv dt related to dr dt? There is a typo here that should say if h is a constant. Okay? So dv dt is d dt of pi/3 r squared times h. Now h is the constant. So let's pull out all of the constants. So that's pi/3 times h, those are all the constants, times, now I need to take a derivative of the r squared, right? So it's 2r dr dt. Yeah.
So on the one above,
Yeah.
I just don't get how it's pi/3 r squared.
Well, it said r is a constant,
Which means?
which means it's like 5 or 3,
Okay.
right? So it's a coefficient. So if this was a 5 squared, right?
Zero.
Well, it would just all be a coefficient, right? So if I had, for example, pi/3 times 5 times h, and I wanted to take a derivative of that,
Or no, it'd be pi/3 pi.
times dh dt, right? So that's what I did. pi over 3 r squared times dh dt. So all of these were constants, and they all came to the front. And now I just have dh
Why the r
dt.
squared?
Because the r is a constant.
Oh,
it's
right.
it's like 5.
And then you did the dh dt because it's
That's the variable that you're taking a derivative of. Okay, now how about dv dt related to dr dt and dh dt if neither of them are constants? Well, now, if v is 1 over 3 pi r squared h, dv dt is pi over 3, right? Those are the constants, right? I'm gonna pull those out. And then here, it's product rule. Okay? So it's going to be r squared dh dt plus 2r dr dt times h.
Put the H before it.
It doesn't matter. Again, once we solve the full-fledged problems, we're going to like end up substituting numbers for all of them and get like actual values. You know? All right. Right now we're just getting the hang of like how to treat something as a constant and not. Okay. Oh, the good old triangles. So the base B of a right triangle is increasing at a rate of 3 centimeters per second, while the height is decreasing at a rate of 2 centimeters per second. So you've got, okay, so the first thing I do here is I draw the triangle, because there is no way you can solve these without. So B and H. The base is increasing, the height is decreasing. So basically, if you think about that, you have something that looks like this. You had, let's say, you know, a triangle like this, right? Then this is like morphing, right? But like it's like a continuous thing. Then like the height got smaller, but the base got bigger. Then the height got even smaller, but the base got even bigger, right? So that's what's happening. And now it's telling you when B is 4 and H is 3, find some rates of change. So you're like, you're watching this thing happen. It's like this continuous motion thing. And imagine like you're standing there with like a still camera, and at the split second where this is equal to 3 and this is equal to 4, you snap a picture, you freeze the frame, and you're like, okay, at that instant, how fast is the area changing, or the height, or the perimeter, or the whatever? Because let's just take area. When the triangle is, you know, this large, or maybe when it's this small, the area might be changing at a faster rate here and at a smaller rate here, depending on what the situation is, right? But we want to know at this particular point in time, what's the rate? Okay, so that's what we're doing. Okay, so now, let's read this again, all right? The base B of a triangle is increasing at a rate of 3 centimeters per second. This is the rate of change of B. In other words, dB dt is, you know, the rate of change is 3 centimeters per second. And is that base increasing or decreasing? What does it say? Increasing. So does that mean it's positive rate or negative rate? Positive rate. The height is decreasing at a rate of 2. So dh dt is negative 2 centimeters per second. All right. And then we want to see what happens when the base is 4 and the height is 3. So look at this. I haven't even started solving this problem, and look at how much I've already written down. All right. Okay, so we want to find the rate of change of the area. Okay, just like with optimization, whatever you were trying to maximize or minimize, you had to write an equation for that quantity. Same thing here. You want to relate what you want to find with what you have. And what we want to find is dA dt. Okay? And so how is area related to the stuff that we have? Well, area is half BH. Okay, so let's take a derivative then. dA dt, so d dt of A is d dt of half BH.
How do you that dBdt is 3 centimeters?
It told me somewhere here. The base is increasing at a rate of 3. So half is a constant. I'm going to move it to the front. So dA dt is half d dt of BH. Okay? Here we go. So dA dt is equal to half, I got to do product rule here. So that's B dH dt plus dB dt times H. Okay? All right. Now that I've taken a derivative, I need to substitute all the quantities that I have. Do I know what B is? It's 4, right? So I say this is equal to half times 4. What's dH dt? -2 plus dB dt is 3. H is 3. So together, all of that is 1/2. It is. It's like magic. Because it's like -8 plus 6 is -4 or 2. Yeah.
For like the actual problem, like you said, it says like it's increasing at a rate of 3 centimeters and decreasing at whatever. Like, didn't you say like it's changing at like it's different at different times? So at like at what time is that?
Okay, so the rate is changing.
Is it at a constant?
Yeah, these are changing at a constant rate, but then at that point, the rate of change of the area is that. Okay? Yeah.
Why is it 1/2?
Because -8 plus 9 is 1 times 1/2. Okay, so here, let's see what it is that we found. B, right? Let's see units a little bit. Let's talk about units. B is the base, and it's in centimeters, right? dH dt, that's centimeters per second. dB dt is centimeters per second. H is in centimeters. So look, I've got centimeters squared per second plus something else that's centimeters squared per second. All right, you have to make sure that you're adding things of like the same units, right? So this is also centimeters squared per second. Okay. Now, how is the length of the hypotenuse changing? So that's C, right? We're going to call it C. All right. Well, if I've got a base and a height and C, how are all three of those related? Pythagorean Theorem. So B squared plus H squared is equal to C squared. Okay? So now let's take a derivative. D dt of this and d dt of that. So 2b dB dt plus 2h dH dt is 2c dC dt. All right? Chain rule, chain rule, chain rule. Now I can cancel out all the 2's So let's see if I have values to plug in here. Do I know what B is? I did, because it was supposed to be 4. And H was 3. Oh, shoot, but I don't know what C is. But wait, can I find out what C is at that point?
Yeah.
How much would it be? 5. So let's plug it all in. 4 times 3 dB dt plus 3 times negative 2 is equal to C 5 dC dt. You do Pythagorean Theorem.
How do you know that
3 squared plus 4 squared equals 5 squared.
DHDT is negative 2?
It said so in here.
Oh,
Yeah. So now you solve. dC dt is 6 over 5 centimeters per second. Okay? Solving, and so on. All right. Next, I want to find the rate of change of the perimeter. So basically dP dt.
How do you know it's centimeters?
All sorts of like tongue twisters. Because it's the rate of change of C versus time, right? So C is length, centimeters per time, per second. Okay? All right, dP dt. Well, now we need the perimeter. Well, what's the perimeter of that triangle? P equals B plus H plus C. Just random letters at this point, right? It seems like. Okay, now let's take a derivative of all of it. So dP dt equals to dB dt plus dH dt plus dC dt. And again, we're reusing the same things from above, right? dB dt, last time we checked, was 3. dH dt, negative 2. dC dt, we just found it, is 6 over 5. So dP dt, 11 over 5 centimeters per second. All right. Lastly, now we want the rate of change of the angle theta, where theta is the angle where the base and the hypotenuse intersect. Okay, now I need to draw that again. Here is the base, here is the hypotenuse. They intersect right here, that's my theta. And I want d theta dt. Oh, well now, how do I relate that angle to what I have? Sine, cosine, tangent. Since I was initially given, what do you call those? The legs, let's go with tangent. Tangent of theta is h over b. Now, I need to take a derivative of both sides. What would the derivative of tangent be? Secant square theta d theta dt equal to, guess what? What rule is that? Quotient rule. So low d high, oh my, take high d low, cross the line and square the low.
How many numbers have we said?
It's definitely tongue twisters. Yeah. It's all just letter, yeah. Okay, so now, what are we solving for? D theta dt. Well, that pesky little secant square needs to get out of there. Divide by secant square theta is the same as multiplying by 1 over secant square theta. Okay, we're going to ignore that for a little bit. D theta dt is equal to, let's see what we can substitute here. What was B? 4. dH dt minus h is 3. dB dt also 3 over 4 squared. Okay, here's where the real cool stuff comes in. What's 1 over secant these days? Cosine. So 1 over secant squared is cosine squared theta, isn't it? Look at this triangle. If this is 3 and 4 and 5, what's cosine of theta? Oh no, it's not like that. It's 3 here and 4 here. What's cosine of theta? 4 over 5. So cosine squared theta is 4 over 5 squared. How cool is that? Who would have thought that was coming, right? Not me. And so look, this 4 squares also cancels with that 4 squared. So what I have left is d theta dt. In the numerator, -8 minus 9 is -17 over 5 squared, which is 25. Units. Angle divided by time. So radian per second. Whew. That's a...
So it can be negative like that?
Can it be negative? No, you know though. You know though. Why is it negative? What does it mean that it's negative?
It's getting smaller.
It's decreasing. And does it make sense that it's decreasing? Look at the progression of the triangle. Look at how theta is getting smaller. Isn't that cool? Oh my. What a wonderful way to like end the school day, right? Related rates. This has been a great day and it's not even over yet. Okay. So now that we're
It's like 3 pages.
we haven't even done an actual problem yet.
We haven't?
No, we haven't.
That last one was, this one.
Huh?
This one was the problem?
These are the baby ones.
Oh.
So, no, we're finishing this today, no?
Well, let's see how far we get to.
This is
I did use some
like a
bonus time
hard
with
class.
e-period today, huh?
This is like a hard class.
If I remember correctly, I did tell you guys not to miss this class.
I almost did.
But then, you know, the
Not like-
divine powers were in our favor here. Okay. So, the math gods were in our favor. Okay. So let's talk about some strategies before we start solving some real problems. Okay. This first one is making a reappearance. Understand the problem. Yes, we got to understand the problem. What is it? Identify what is it that you're looking for. Identify what is it that you know. Okay? Develop a mathematical problem. I'm sorry. We're starting with a mathematical problem. Develop a mathematical model. What is a model? Is it a picture? What's a mathematical model? It's the function. You start with a picture, right? But then you want to eventually go to a function that relates everything you have. Now, this one is important. Be sure to distinguish constant quantities from variables that change over time. Okay? Okay. Next, write an equation. And then we know differentiate both sides implicitly. Chain rule is important. Okay, then comes substituting values. Okay, this is important. Students often rush to substitute their values. If a variable, if a quantity is not constant, you cannot put in the number from before because the derivatives will be 0. Okay, then we interpret our solution. All right. Without further ado, let's go. A hot air balloon. Okay, a hot air balloon is rising straight up from a level field, and it's being tracked by a rangefinder 500 feet from the liftoff point. Okay, what? Let's draw a picture. Yes, Here's the ground, okay? The level field. The balloon is rising straight up. So here's the balloon. 500 feet over, there is this machine. It's a rangefinder. It's like bolted to the ground. It's like fixed in there. And basically it tracks the balloon and it finds like, you know, how high or low or whatever, right? Its position. So this is the rangefinder. Okay? At the moment, the rangefinder's elevation angle is pi over 4. Okay, so there is an angle theta here. That's the angle of elevation. The angle, so theta is pi over 4. The angle is increasing at a rate of 0.14 radians per minute. Well, that means d theta dt is 0.14 radian per minute. Because it's the angle of elevation and it always goes from like here up, from the horizontal up. How fast is the balloon rising? If this is y, then we want dy dt. Okay? So again, I haven't even begun, like I just finished reading the problem the first time. And, you know, look at all the stuff I've already noted down. Okay? So, we want dy dt. We're given angle. Well, how do we relate y with angle? Tangent. So, tangent of theta is y over 500. Okay. Is this 500 changing? It's not, right? This is like a fixed thing on the ground. This is not a variable that will be changing. That's why I didn't say y over x. I did y over 500 because it's a constant. Okay? All right. Let's take a derivative. Secant square theta d theta dt is equal to 1 over 500 dy dt. Okay? What am I solving for? Dy dt. So let's move 500 over to this side. 500 secant squared theta d theta dt is dy dt. Okay? Okay, what the heck is this secant squared theta business? When is this happening? When theta is what? Theta is pi over 4. When theta is pi over 4, what's secant of pi over 4? What's cosine of pi over 4? 1 over root 2 or root 2 over 2. So secant is just root 2. So this is 500 times root 2 squared times 0.14. Okay. Look at this. Root 2 squared is what? 2. Times 500. You guys know. 1,000. 1,000 times 0.14. How many? 140 feet per minute. That's dy dt. I know. That's definitely right. Yes, it's so gratifying. So this will be like a multiple choice question on the AP test.
What? That's so nice.
How long are they?
Huh?
How many responses?
6 pure response questions, but each have like ABCs or ABCDs, and
How long does that take? Like an hour?
it's 15 minutes per question. That's the allotted time.
Per question.
15 minutes per FRQ question.
That's not that bad.
Multiple choice.
I'll tell you guys. I have like a thing. I showed E period, but I haven't. I'll show you guys. Okay. We gotta go until 3:15. Okay. Oh, look at this police cruiser. It's just like it's so LA. A police cruiser is chasing a car. So look, a police cruiser approaching a right-angled intersection from the north, right? So here's the intersection. From where to where is the cruiser going? Okay, it's going down, right? From the north to this, so, down this way. It's chasing a speeding car that has turned the corner and is now moving straight east. Okay? When the cruiser is 0.6 miles north of the intersection and the car is 0.8 miles to the east, the police determine with radar that the distance between them and the car is increasing at 20 miles per hour. So if this is the cruiser and this is the speeder, right? The car. Well, what's the distance between them? It's this. That is changing at a rate of 20 miles an hour. So if I call this X, Y, and Z, that means dz dt is 20 miles an hour.
But you wouldn't use Y and X. We know that.
Don't we know it already?
We know what X is.
We know it at one point, but it's continuously changing because they're like in pursuit, right? It's in pursuit, but the snapshot is when it's 0.6 miles north and 0.8 miles to the east.
So they're not constant.
Huh?
So it's not going to be like a constant. The 0.6.
It will be. Okay, so look at what is constant. If the cruiser is moving at 60 miles an hour, so if dy dt, right, the cruiser is dy dt, and it's moving at 60 miles an hour, but is dy dt positive or negative 60? Well, this distance is decreasing, so it's negative 60 miles an hour. What is the speed of the car? What's dx dt? So these are changing. They're all changing because they're in like hot pursuit here, right? But you freeze frame at the point where this is 0.8, this is 0.6, okay? And then you're like, okay, what's dx dt at that point?
Well, isn't it 28?
Well,
Or like
no.
positive 8 from east?
No, this is the distance when it's 0.6 miles north or 0.8 miles to the east. So what we want to do now is, look, we've got this x, this y, this z. We have to connect them to each other. And the way you connect them to each other is this. Okay? Now, you take a derivative. So 2x dx dt plus 2y dy dt 2z dz dt. Okay, 2's go away. Now let's see what it is that we have. X is the position, right? It's 0.8. dx dt is what I need to find. Y is the position, 0.6. dy dt, negative 60. Okay, z is this distance. How do I find that? Pythagorean Theorem, right? 0.6 squared plus 0.8 squared is equal to z squared. Z is 1. So you can either do it and then recognize that's like a 6, 8, 10 triangle. Okay, like a 3, 4, 5. So z is 1 times, what was dz dt? 20. So now dx dt, I don't know how much it is, 70 miles an hour. Okay. All right, I do want to do this one more and then we'll stop.
What do you have to use calculator?
Mm-hmm. Yeah, especially this next one. Okay. Water runs into a conical tank. Oh, I know. It's like a vessel in some company, in some like refinery, just think of it as some like industrial location.
Are we supposed to know that?
Well, now you do. This is a VIP. It'll show up all the time. It's a conical tank. Get it? It's a cone.
Never thought you'd learn vocab.
It's a membrane word.
I hated Membi.
I actually really like
Me too. I like that. Me too. I like it.
I would be all over membrane if I had to do it. I'm such a like a grammar spelling nerd.
Alex was like look up there.
I did learn words.
Alex was the
I like learning.
Alex and Membi were so bad. Except when you were
I think their combination was bad.
Yes.
It's like hydrogen and oxygen, right? And then like they might, or like carbon and oxygen, really good, but together carbon monoxide, not so good, right? I think that it was that. No more Alex. Alex is gone.
Thank God.
Okay, so water runs into a conical tank at a rate of 9 cubic feet per minute. Right? The tank, not tanks, stands point down and has a height of 10 feet. There's the police cruiser. Oh boy. And a radius of 5. Okay. How fast is the water level rising when the water is 6 feet deep? Oh boy. So look, there is some water in here, right? The water has a height of h. So what we have is dv dt, 9. What we want is dh dt. Now, wouldn't you know it? But when you have a situation like this, right? And if you just isolate this part, guess what happens? This, not only is it a right triangle, it creates proportional triangles like you learned in geometry. Oh my word. So if this is 5 and this is 10, well, in the little triangle, this is R and H. R and H. Well, now there is a little proportion here because R over H is equal to 5 over 10. Isn't that cute? Okay, let's let that simmer there for a minute.
Well, don't we know that H is 6?
No, not yet. Not yet. We can't substitute that in just yet. So what do we know about the volume? 1 over 3 pi r squared h. Okay, but now look. I can't leave it like this because if I start doing product rule, then I'll have dr dt and dh dt. But I have no information about r or dr dt. So I need to eliminate r and just work with h. Well, luckily, I can do that with this proportion. Because what's r? R over h is 1/2. R is h over 2. So now I go over here and I say this is v equals 1 over 3 pi h over 2 squared times h. Okay?
Don't you know R?
No. Well, we know R for the whole thing, but not for the water. Right? Yeah.
The smaller triangle in the triangle.
Mm-hmm.
That's correct.
Yeah. Okay, so V,
Also, what does it mean at 6 feet?
here, I'll tell you right now. So this is going to be, like, when you multiply all this out, it's pi over 12 h cubed. Okay? So now, what's dv dt? Pi over 12 times 3h squared dh dt. Now that I've taken a derivative, now I can substitute the numbers that I know. All right? So, dv dt, I don't know what that is. Oh no, I do know what that is. It's 9. Equals pi over 12 times 3. Now I can put in that h was 6 squared. dh dt. Okay? So this is 9 equals 436 over this. It's 9 over 9 pi dh dt. So dh dt is 1 over pi, which is 0.318 feet per minute. Okay, and this is where